Ever wondered what it really takes to get under the hood of a Linux server to, master its essential tools? Today, we're taking a shortcut, a deep dive into the indispensable toolkit of a Red Hat certified system administrator. We're focusing on what are often called administrative utilities.
Yeah.
Yeah, the real nuts and bolts that make a Linux system run smoothly, securely, and efficiently. Our main source for this exploration is RHCSA, Administering Linux Systems. It's really packed with practical wisdom.
It really is. And what's fascinating, I think, is how this knowledge is just foundational for almost any modern computing environment. It's not just for big enterprise admins,
Yeah.
whether you're managing servers for a company or just keeping your home media server running strong. Understanding these utilities is key. It really boils down to getting proficient with users, services, networking, security, all the bits that ensure things are resilient and reliable.
Right. So our mission today is basically to pull out the most crucial takeaways from this guide. We want to make sure you walk away with a clear, actionable picture of what it really takes to administer a solid Linux system. Maybe even pick up a few pro tips along the way. Okay, let's start with the human element. Users and groups. Why is managing who can access what so critical? Like the first line of defense, maybe?
Oh, absolutely. It's the bedrock of security and just plain organization. I mean, every single interaction from logging in to running a simple command, it's all tied to a user or a group. So the core tools, things like useradd, passwd, usermod for users, and then groupadd, groupmod for groups.
Yeah.
They let you control that access. And there's a really key distinction between system users like root, the one with all the power, and regular users who operate with limited defined access. That's that whole least privilege idea.
That makes complete sense, the least privilege principle.
Yeah.
So when we use these commands, useradd and so on, where does this information actually live on the system? What's the structure underneath?
Yeah, good question. That's where the classic files etc pass root and etc group come in. They're basically just plain text files, acting as the central list for all user and group info. When you run useradd or groupadd, the command is actually just writing a new line, a new entry into these files. And importantly, each user and group gets a unique number, a user ID or UID, and a group ID, GID. That's how the system internally tracks permissions and ownership using those numbers.
Okay, that gives us the foundation. Let's dig into some more specific tasks then. What about secondary groups? How do they fit in, and how does an admin quickly check a user's setup? And maybe touch on things like changing a user's shell or setting password expiration.
Right. Secondary groups are super useful. They let you grant users access to different resources without, giving them overly broad permissions or making duplicate accounts. Usermod is your main command for adding or removing users from those secondary groups. And to check, the ed command is great. It shows you the user's UID, their primary GID, and all the groups they belong to. Groups just list the names. Simpler. For those other things, Quiche lets you change the login shell maybe to bash or dash or something else. DFN modifies finger information. Honestly, that's a bit of an older command you might see, but probably won't use much these days. But geez, that one's crucial. It's for setting password expiration policies, forcing regular updates, which is a big security plus, and thinking about the real world. You're using these skills constantly, designing group structures for a new project, carefully changing access when someone's job changes. It's also your first stop for troubleshooting. User can't access a file, check their group memberships with ed. That least privileges thing isn't just a suggestion, it's really your frontline defense. Overprivileged accounts, they're prime targets. Huge attack surface.
Okay, so we've covered who can use the system. Now let's talk about what makes it actually run. If the server's a city and users are citizens, then system services. They're like the power grid, the water, the transport, right?
Yeah.
Always running in the background. What exactly are these things?
That's a great analogy, yeah. System services are essentially those background programs. They're always running, providing core functions, networking, maybe printing, file sharing, databases, web servers. They're critical because, well, they provide the infrastructure that everything else relies on. And the modern way to manage these in most G and Linux systems is typically systemed. And the command you'll use almost all the time is systemtitl.
Systemtitl, right? That's the key one.
Yeah.
So how do you use it? Starting, stopping services, restarting them. And the really important bit, how do you make sure they fire up automatically when the system boots?
It's pretty straightforward, actually. Systemtitl start, service name, systemtitl stop, systemtitl restart. Those are the basics. To make them start at boot, you enable them. Systemtitl enable service name and checking their health. Systemtitl status service name. That gives you a quick look at whether it's running, any recent errors in the logs, that kind of thing. All these services are defined by what are called service units.
Yeah.
Just simple configuration files telling systems how to manage them.
Okay, now here's where it gets maybe a bit trickier. Dependencies. Why is the order services start in so important? What happens if things start out of sequence?
Find out.
Dependencies, yes, vital. It's like building something. You need the foundation before the walls, right? Services often rely on others. A web server, for instance, needs the network to be up and running before it can start listening for connections. So in those service unit files, you have directives like after, before, requires, and wants to define these relationships. And there's a subtle but important difference. Requires means the other service must be running. If it fails, yours won't even try to start. Wants is softer. It prefers the other service, but it'll still try to start even if the wanted service fails. That's good for non-critical things, adds a bit of fault tolerance. You can actually see these chains with systemtable list dependencies service name. Super helpful for troubleshooting, especially boot problems.
Makes sense. So, practically speaking, day to day, when would an admin be using these system TESL skills beyond just the initial setup?
Oh, all the time. Routine maintenance is a big one. Restarting a database after you tweak its config, for example. Or applying updates might require stopping and starting services. Setting up new services, you'll definitely use enable to make sure they persist after a reboot. And troubleshooting, of course, web server down. First check is systemtable status HTTPD or whatever it's called, see why it's down. Then maybe try a restart. It's fundamental diagnostics.
All right, let's shift gears a bit. We've got users managed, services running now, keeping an eye on everything, system monitoring. Why is being vigilant so key?
Well, vigilance lets you catch problems before they become emergencies. It's proactive. You can spot things like resources running low or weird activity before it takes the system down. Essential tools here. Top is a classic. Gives you that real-time view of processes, CPU, memory usage. Quick way to spot a runaway process. And HTOP is like top, but often considered more user-friendly, interactive, easier to kill processes, sort things differently, visually clearer for many people.
Okay, top and HTOP for the immediate picture. What if you need to dig deeper into memory usage or see how the disks are performing over time?
Yeah, for that you'd look at tools like vmstat and iostat. Vmstat gives you virtual memory stats, but also disk and CPU info. Things like how much memory is free, how many processes are waiting for CPU time, if the system is swapping memory to disk a lot, that kind of detail.
Yeah.
iostat is laser focused on disk I/O. Reads, writes, data transfer rates, how long operations are waiting, helps you spot disk bottlenecks as one disk getting hammered is an app thrashing the storage.
So that covers active processes and resource trends. But what about looking back? Finding clues about something that happened earlier, maybe overnight, or auditing past events?
That's where logs are indispensable. The syslog system traditionally collects messages from services all over the place. With systemed, you'll often use journal XEL to query the system journal, which gathers logs in a more structured way. You can filter these logs by severity, debug, info, warning, error, to zero in on problems. And for really comprehensive historical data, there's SAR, which comes with the systat package. It collects all sorts of system activity data over time so you can spot trends, anomalies, performance patterns.
So putting it all together, how does this monitoring toolkit help with actual troubleshooting? What's the practical payoff?
It's your diagnostic suite, really. Identifying bottlenecks. Is the CPU maxed out? Are we out of RAM? Is the disk I/O the slow point? For digging into why a specific application is misbehaving, Strace is amazing. It shows you the system calls a program is making. Is it stuck waiting for a file? A network connection allsoft list open files shows you everything a process has open files network sockets. Great for tracking down resource locks or unexpected connections. And for network issues, TCP-dump lets you capture the raw traffic, while netstat gives you connection stats. Monitoring isn't just watching numbers flash by. It's about spotting patterns, like a sudden spike in disk writes on iostat. Could be a backup kicking off, or it could be a rogue script. These tools let you figure that out.
Okay, next up, safeguarding systems, backup and recovery. Why is this often seen as like the most critical admin task, the one you just can't afford to mess up?
It's pretty simple, really. Without good backups, one single failure, hardware dies, ransomware hits, someone makes a big mistake, can wipe out everything, all your other work is gone.
Yeah.
Data loss can be absolutely catastrophic. And there are different ways to back up, right? A full backup copies everything. Incremental just copies what changed since the last backup, whatever type it was. Differential copies everything changed since the last full backup. Which one you use depends on, how much data you can afford to lose, how quickly you need to recover, how much storage you have. Trade-offs. Core tools for this. tar is classic for bundling files and directories into archives. Dump is designed for backing up entire file systems at a lower level. And orsync is fantastic for synchronizing files efficiently, especially over networks.
Right. So Practically, where do commands like cre, scp, mv fit in? Are they used for backups too? And crucially, how do you get the data back?
Yeah, CP and MV are more for quick, local copies, like maybe backing up a single configuration file before you edit it. Simple stuff. SCP is for secure copy between systems, so useful for maybe pushing smaller backup archives offsite. Restoration depends on how you backed up. If you use tar, use tar-x to extract the files back. If you use dump, there's a corresponding restore command specifically designed to read dump archives. These tools let you rewind, basically, bring things back to a known good state.
Okay, but making one backup is one thing. How do you make sure they happen reliably, consistently, and that they'll actually work when you need them most?
Automation is absolutely key here. You schedule backups using cron for jobs that run at fixed times, like every night at 2 a.m. Or anacron is useful for systems that aren't always on, like laptops. It ensures the job runs eventually, even if the machine was off at the scheduled time. Backup rotation is another critical concept. You don't just keep one backup. You keep multiple sets, dailies, weeklies, monthlies, and cycle through them. Protects against overwriting your only good copy with a bad one. But honestly, the biggest mistake people make isn't forgetting to back up. It's forgetting to test their restores. A backup you can't restore from. It's worse than useless. It's a false sense of security. You have to test them periodically.
Yeah.
And tools like MD5sum or SHA-256sum help here too. They create a unique digital fingerprint for files or archives. You can calculate the sum when you back up, store it, and then verify it later to make sure the backup hasn't been corrupted. Integrity checks.
So this really forms the core of any disaster preparedness plan then.
Exactly. Backup and recovery, tested and reliable, is the absolute cornerstone. It's about protecting configs, user data, databases, everything. It ensures that even if the worst happens, hardware failure, cyber attack, simple human error, you can get back up and running. It's about integrity and availability.
All right, let's shift to the network, navigating the digital highways. How do admins make sure systems can actually talk to each other both locally and out on the internet?
Yeah, networking is all about configuring how your system connects, managing network interfaces, Ethernet cards, Wi-Fi, maybe even VLANs for segmenting networks. The main command these days is IP. It's replaced the older ifconfig mostly. You use IP to set addresses, manage routes, bring interfaces up or down. On systems using Network Manager, which is common on desktops and many servers now, NMCLI is often the command line tool you'd use to manage connections. And fundamentally, you need to understand the key protocols. TCP/IP is the foundation. DNS for translating names like www.google.com into IP addresses. DHCP for automatically getting an IP address. HTTP for web traffic. Knowing how these fit into the OSI model, that conceptual layered framework helps understand how data flows and where problems might occur.
Okay, systems on the network, how do you see what's actually happening out there? Traffic flow, active connections, that sort of thing.
Visibility is crucial. TCP dump is incredibly powerful. It lets you capture and see the raw network packets flowing in and out. Amazing for diagnosing tricky communication problems. NetStat gives you a summary view, active connections, which ports are listening, the routing table, interface statistics, helps you see who's connected to what.
What about setting up specific network services, like SSH for remote login or a web server?
Right, so you'll configure services like head for secure shell access, maybe VSFTPD or similar for FTP, and HTTPD, Apache, or Ravinx for web serving. Each has its own configuration files. For SSH, it's usually etc config. For Apache, httpd conf httpd.conf. Knowing where these files are, how to edit them safely, and then using systemtl to restart the service to apply changes that's standard practice.
And it feels like security is just woven into everything network related, doesn't it? How do admins lock things down?
Oh, absolutely. Network security is non-negotiable. You use firewalls. Iptables is the traditional powerhouse. Firewall is a more modern, dynamic front end, often used now. You define rules.
Yeah.
What traffic is allowed in, input, what's allowed output, what can pass through if the system is routing forward. Default deny is usually the safest starting point. Network segmentation is another big piece, using VLANs or different subnets to isolate parts of your network. So if one part gets compromised, hopefully it doesn't spread easily to others. Reduces the blast radius.
So for you, the listener, if things go wrong with networking what are the first troubleshooting steps? Where do you even start?
Start simple. Connectivitybasics.ping, just to see if you can reach the other machine at all. Is basic IP connectivity working? Traceroute, or MTR, which combines ping and traceroute, shows you the path packets are taking. Is it getting stuck somewhere along the way? High latency on one hop. If the basics work but a specific service doesn't, like you can ping but can't SSH, then you start looking higher up. Is the SSH service running? system telestat issue. Is the firewall blocking the port? Check firewalled or iptables rules. For really deep dives, TCP dump is your friend to see the actual conversation attempt, or Wireshark if you prefer a graphical view of captured packets. Thinking about that OSI model helps narrow it down. Ping fails, probably layer 3 network issue. Ping works, SSH fails. Could be layer 4, firewall, or layer 7, SSH service itself. Gives you a roadmap.
Okay, finally, let's bring it all together with the foundation, security principles. Why are these underlying philosophies so vital? How do they guide an admin?
They're the guiding stars, really. Every decision should filter through them. Least privilege, we mentioned it before, users and processes get only the permissions they absolutely need, nothing more. Minimizes damage if something goes wrong. Separation of duties is another key one. Don't have one user or process controlling everything critical. Isolate sensitive tasks. Makes it harder for one compromise to take down the whole ship. Following these makes the system inherently more robust.
And what specific threats are common in the Linux world? And what are the big gun tools designed to counter them at a fundamental level?
Threats are varied, Malware exists, though maybe less prevalent than on other platforms. Viruses. Unauthorized access is always a concern. Attack types range from phishing attempts trying to trick users, to social engineering, to denial of service attacks trying to overwhelm resources. Big tools. SELinux Security Enhanced Linux is huge. It enforces mandatory access control, MAC. Unlike standard permissions where the user decides who accesses their files, MAC enforces system-wide policies defined by the admin. Even root can be constrained. It provides much deeper security. And of course, the firewalls we talked about, iptables, firewalled controlling network access is absolutely fundamental defense.
Okay, beyond SELinux and firewalls, what other specific tools come into play for encryption, authentication, maybe finer-grained access?
Yeah, there's a whole toolkit. OpenSkull is the Swiss Army knife for anything cryptographic, creating certificates, antigen keys, encrypting data. OpenSkull provides that secure remote access using encryption for the connection. NotebookLM, GTGs for encrypting files and emails, and verifying authenticity with digital signatures. And access control lists, or ACLs, get fackle, set fackle commands, let you set more granular permissions on files and directories than the standard user group other model allows. Useful for complex sharing scenarios.
What about passwords? We hear about breaches all the time. What's the current thinking on keeping passwords secure beyond just making them complex?
Complexity and length are still important, but policies are key. Forcing regular password changes, expiration. Checking against dictionaries of common passwords. Preventing reuse. Tools like passwd and passwd manage the basics, but paid unpluggable authentication modules is the real engine behind it. It's super flexible, lets you plug in different ways to authenticate users, and critically, multi-factor authentication, MFA-CNS. Having something you know, password, plus something you have, like a code from an app or a hardware token. That adds a massive layer of security. Even if a password gets stolen, the attacker still needs that second factor. It's becoming standard practice for good reason. And don't forget auditing. How do you know if your security is working or something fishy is happening? Tools like Audit create detailed logs of security-relevant events. AutoPort helps you analyze those logs. And OpenSCAP is great for compliance scanning. It checks your system configuration against security benchmarks and standards, helping you find and fix vulnerabilities proactively. Security isn't a one-time setup. It's ongoing vigilance and maintenance.
Wow. Okay, that was quite a journey. We've really covered a lot of ground from managing users and groups, keeping services running, monitoring system health, the absolute necessity of backups, navigating networks, and tying it all together with those core security principles. An incredible breadth of knowledge for administering GNU Linux.
Absolutely. And understanding how all these pieces fit together, that's what equips you, the listener, to manage systems that are not just functional, but also secure, efficient, and reliable. It connects all these diverse skills into that bigger picture of truly robust system administration. It's not just about knowing the commands, it's understanding the why and the how they contribute to a healthy system.
So here's a final thought to leave you with. Given this constantly changing landscape, new digital threats emerging, systems getting more complex, how do you think the role of a Red Hat certified system administrator might continue to adapt? What new tools or ideas might become essential to maintain that system integrity and performance in the years ahead?